In this demonstration, we are going to show a collision prediction system which uses only pairwise range measurements. As autonomous vehicles become more and more common, how do we avoid collisions between them? LiDAR and vision sensors can be part of the solution, but the smaller and more distant other vehicles are, the harder they are to detect. In this demo, we explore using ultra-wideband range measurements made between two objects to predict that a collision is imminent. We assume no infrastructure, only the range between the two nodes is used, and no other sensing modalities. Collision prediction is something every driver experiences every day. The dividing lines and the vision of the surrounding help us with this task. When a car is moving in your direction from the other side of the road, using your vision, you understand it is off the side of you on the parallel line. Imagine that everything is road with no dividing lines or speed limits and cars can go in any direction. Driving on this road would make anyone anxious. Now for the same situation, imagine that you have no vision of the surrounding and you have only distance measurements between you and the incoming car. Then you wouldn't be able to determine if the car is going to hit or miss your car. An impeding collision should be predicted whenever the two nodes will be less than a threshold distance apart within a short period of time. Recent measurements are used to extrapolate the future range. In particular, since a squared range is parabolic with time whenever the velocity is constant, we use a parabolic fit for extrapolation. Parabolic extrapolation can be done in real time with low computational complexity, but measurements are noisy, thus the predictor is imperfect. The purpose of this demo is to show that the algorithm can be implemented on a low-cost microcontroller in real time and to provide intuition about its performance. In real settings, however, there is noise in the measurements which sometimes affect the regression-based extrapolation, hence may lead to false alarms. We develop a system to enable pairwise range measurements from two-way ultra-wideband ranging. The system uses secondary narrowband radio to handle frequency synchronization and data communication, while the ultra-wideband radio handles timestamp messages. Here, we show the performance of the collision prediction system in an experiment. For this experiment, we use a pair of tanks, each equipped with an ultra-wideband sensor to measure its pairwise distance. Each node has a blue light indicator to show predicted collision. As shown in this video, when there is an inbound collision, a blue light is on. The experiment also shows that when nodes pass by one another, the light does not turn on, showing the use of pairwise distance measurements in accurate collision prediction. For more information, please visit the website for SPAN Lab at Washington University in St. Louis.